There are two charges, 2 microcoulomb and 4 microcoulomb, both are positive, placed 10 centimeter apart. So 2 microcoulomb is at A, 4 microcoulomb is placed at B. So AB will be 10 centimeter. Calculate the total electric field at midpoint of the line joining them. So C is a midpoint, so that AC equal to 5 centimeter. Even BC also 5 centimeter. Second part, find a point where electric field of the combined system is 0. We are trying for the first one. The electric field intensity formula is KQ by R square. At C, A produces electric field intensity. That will be K Q of A by R between AC square. Same way, C have another field due to B. That will be K Q of B by square of R between B and C. Now, since electric field is a vector quantity, whether the magnitudes to be added or subtracted, or we have to use the parallelogram law of vector addition, depends on the directions of A and B. For any vectors, if the direction of vectors are in same way, you can just add their magnitude. If the vectors act in opposite direction, subtract the smaller one from the greater magnitude, then put the direction of the greater one. If they are in different directions other than parallel or anti-parallel, we have to use parallelogram law of vector addition. But here, if you try to see at C, if we keep a positive test charge, the positive source charge at A will repel the test charge towards right. That means electric field at C due to the charge at A will be towards right, I cap. Same point, if we keep a positive test charge and see the effect of 4 microcoulomb, it's also positive. The positive source charge at B will repel the positive test charge towards left. So electric field at C due to B is towards left minus I cap, and at C due to A is towards right. So they are in opposite direction. Then check whether the magnitudes are equal or different. The distances AC and BC are same, 5 centimeter each, but charge of A is smaller compared to charge of B, which is 4 microcoulomb. So ECB magnitude will be definitely greater than ECA magnitude. Then the total electric field at C will be ECB, which is greater magnitude, minus ECA. In the direction of the net electric field will be that of the greater one, that is along left side, B to A or minus I cap. So ECB greater, ECA smaller, subtract, put the direction of the greater one. Now ECB and ECA you can substitute KQB by R square BC, KQA by R square AC. Now in this RAC and RBC both are 5 centimeter, you can take common out. K is common, QB and QA are different. So QB value is 4 microcoulomb, QA value is 2 microcoulomb, K is 9 into 10 raised to 9. RAC and RBC are equal, which is 5 centimeter. When you square, it will be 25, but centimeter to conversion, meter conversion make 5 into 10 raised to minus 2 meters. So 25 into 10 raised to minus 4 will be the R square AC or BC, which are same. Now substitute the values. Now 4 minus 2 microcoulomb common out. K 9 into 10 raised to 9. R square is 25 into 10 raised to minus 4. 4 minus 2, 2, 2, 9, 18. So 18 by 25. 18 by 25 exponent 9 plus 4 will go on the top. Minus 4 will go to the top as plus 4. So 13. 13 minus 6, 7. Now this can be done by changing 18 by 25 you can divide, or you can change 25 as 100 by 4. So 100 will remain here, 4 will go to the top. 4 into 18, 72. 72 by 100 will be 0.72. Now if you take 1 0 from here, 7.2 into 10 raised to 6. The resultant intensity at the midpoint C is 7.2 into 10 to the power of 6 Newton per Coulomb along the negative x-axis minus I cap. That's the first part. Now to find the electric field at the to find the point where electric field of the combined system is 0, we get another diagram. We have the electric field intensity at another point. It may not be at C. If you take a point on the right side, B is positive, A is also positive. So if we keep a test charge here, both positive charge will repel that to the right. So both electric fields are acting towards the right. So you cannot have zero field here. For zero field, the field of B and A has to be in opposite direction. Even you take a point on the left side of A, this +2 will repel the test charge left, even the +4 will repel left. So since both are like charges, both will repel the test charge towards left. So here also it cannot be 0. Electric field cannot be 0. And the only possibility is the electric field 0 between the two charges, because if you take a point between the two charges, the +2 will repel to the right and the +4 will repel to the left. They are in opposite direction. Then you have to find a point where there is a possibility electric field can be 0, midpoint or right close to B or left side close to A. This is 4. It is a strong charge. So if you take midpoint, at the midpoint, the 4 will have a stronger field intensity compared to 2. Even you go to the right, the effect of 4 will be much greater. So the only possibility is a point close to A. So imagine a point close to A called D. The electric field can be 0 only near a small magnitude charge. Outside can't be 0 because they're in the same direction. So we keep a point D here, so that AD equal to X and BD equal to 10 minus X. So now since the fields are in opposite directions, we have to get field at D, the new point, due to A, magnitude has to be equal to the field at the same point D due to B. The D is not marked, I will mark at the end. This is copied from the previous one. So D is a new point between A and B close to A. Now you can substitute the value of ED and VD. So E equal to KQ by R square. So K QA by R dA square and K QB by R PD square. Now KK get cancelled. QA will be 2 microcoulomb. QB will be 4 microcoulomb. Micro get cancelled. So you can have 2 here, 4 here. R A to D. If you take R A to D as X, then R B to D will be 10 minus X. So 2 K will go, micro will go, so 2, 4. Then you can take the square root on both sides after cutting 2 and 4. 2 will go, 4 will go. So 2 will come here. You take the square root. So 1 by X equal to the 2 become root 2. 10 minus X whole square become 10 minus X. Cross multiplying, root 2x equal to 10 minus X. So X will go left. So X comes common out. Root 2 plus 1 into X equal to 10. So root 2 plus will go to the right as X equal to 10 by root 2 plus 1. You can multiply with the conjugate, root 2 minus 1 up and down, so that you can find the values. 10 into root 2 minus 1. Root 2 is 1.414 minus 1.414 into 10. A plus B into A minus B is A square minus B square. So root 2 square is 2, 1 square is 1, so 2 minus 1. So 10 into 0.414 by 1, 4.14 centimeters. That's from A to D, and we subtract 10 minus 4.14, which is 5.86 from. So the electric field is 0 at a point, 4.14 centimeter from A and 5.86 centimeter from B. Now the modification, what I didn't do in the beginning, we don't want AC, DC, so from the last question. When we don't want C, the field of B and A both are in same direction here. For a vector to be 0 at a point, the first priority is they must be in opposite directions. But here, both electric field of B and electric field of A both are in the same direction, so it can't be 0. So when you take a point on the left side, there also both positive charges will repel the pressure charge towards left. So since both vectors are in same direction, the electric field produced by A and that of B, we cannot have 0 here. Now you try to take central point between the two, but since the distance is same, 4 microcoulomb is stronger, so it will have a stronger field here. So when you go to the right side, as we discussed, the effect of 4 becomes again strong, the 2 becomes less. Even it can't cancel at center, then it cannot even cancel close to 4. So the only possibility is the electric field can be 0 at a point close to the small magnitude charge. Always the electric field intensity can be 0 near the small magnitude charge. Now you take A to D distances x, so B to D. The total distance minus x, 10 minus x. That's what you use here. BD has 10 minus x, BD as x.